Okay, those that were not here yesterday, all we did is we just finished up the notes. Everything was posted that we did yesterday, and we didn't go any further with respect to notes. And what we did then after that is everybody just worked on and completed the rest of the worksheet. Questions you have on anything with respect to central tendencies? Once again, it is trying to find one value that will represent a group of data values. Okay, a sample mean, a population mean. What would represent? What would be one number that represents it all? Okay, a median, a mode, a mid-range. Those are all values that would represent an entire set of data. Questions you have? Once again, most of that stuff you've seen before. Some of it when we start dealing with group data or group data, and also weighted grades. That was a little bit different for you, but it's still the same idea of measure of central tendencies. Today we start venturing into things that you've never seen before, and never worked with and dealt with before in statistics. We start with what is called the measures of dispersion or variation. It is the idea of a standard deviation, a variance in the standard deviation. Okay, we have two sets of data. We have 5 quiz scores. Okay, 2 sets of data there, 5 quiz scores. What I want you to do is I want you to calculate the mean for each one of these test scores. Calculate the mean. Add them up, divide by the total number of values. Calculate the mean. Victoria, what do you get? For which one? For both of them. All right. So, if one person scored on their quizzes for 9 weeks, 82, 94, 90, 88, 86. Their grade is an 88. Their one value that represents their whole set of data is a value of 88, which would be a B+. Another person scores 72, 100, 68, 100, 100. Calculate the average for that. They average out to an 88. They get a B+. Both students get the exact same grade. Now let's take a look at the data. And what I want you to do is I want you to write a sentence that compares these 2 sets of data. Compare and contrast, whatever. If I compare these 2 sets of data, are they similar to each other? Are they different somehow from each other? How would they be different if they're a little bit different? Or how are they the same? And write a statement comparing these 2 sets of data. What would be a statement? We got 82, 94, 90, 88, 86. Then we got 72, 100, 68, 100, and 100. What would be a statement that compares these 2 sets of data? Here's your English thing for the day. Gracias. Trenton would be a statement that compares and contrasts these two sets of data.
I just said the one student has pretty similar scores and the other student has either really good or really bad.
Okay, very similar scores up here. This is really good or really bad. Okay, these are closer together. These are more spread out. Okay, I would tend to think that that would be somewhere in the ballpark of what you wrote down. Okay, these are really clumped together. These are really spread out. Okay, these are really close with all those scores. He is very consistent with all the scores here. This student had good days and bad days. Really good or really bad. But no matter what, they still got the same grade. They still got the same grade. Well, that's what we're going to talk about today, is how these are really spread out, the spread of the data, the measures of variation and the measures of dispersion. It is the measures of the spread of the data. How is it spread out? Is it clumped together? Are they spread out further? Are they clumped together? Spread out? Well, there's ways of measuring these. There's ways of calculating this degree of closeness or spread outness. It's a relative concept. You have to be able to compare one with the other to get that relative concept. The first one we've already dealt with is called the range. You take the largest value and subtract out the smallest value. Big minus small. Largest value minus the smallest value. If we look up here, my largest value in the first set is 94. My smallest is 82. So the range of data is 12. The other one, my largest value is 100. My smallest value is 68. So we have a value of 32 for a range. That range means it's more spread out. 12, it's closer together. It's a relative concept. Let's take a look at two scenarios here. Dual credit, or now it's called College Credit Plus. The College Credit Plus is down in high school. Okay, we have this class right here. College Credit Plus is down in high school. Just members of it. Okay, we can count up the number of people we have. I got first semester, second semester. I could take them and do a statistical analysis on them. Then the second scenario is the College Credit Plus is down in high school as a part of the College Credit Plus group from the University of Findlay. One of these is a sample, one of these is a population. Which one would be if I were to look at the classes at DHS? One of these classes, one of the scenarios is a sample. One of the scenarios is a population. I'm talking about the entity of our class here at Downton High School. If we just took a look at our class at Downton High School and just said, I'm going to do a statistical analysis on that, and then turn around and go to the second one, this class at Downton High School, a part of the entire University of Findlay web of College Credit Plus classes. They have probably 50 schools that teach College Credit Plus through them. One of these is a sample, one of these is a population. Which one's a sample, which one's a population? This class, which one would you be considered as a population? Which one would you be considered as a sample? What do you think, Austin? Okay, so this would be a sample. And then the other one would be, yeah, we're a population. So one scenario is when we just look at this down the College Credit Plus at Downton High School and just say that's all we're dealing with, then I'm going to do a statistical analysis on them. You're a population. But then when I tell you I'm going to do a statistical analysis at Downton High School and want to talk about all the College Credit Plus classes done by the University of Findlay, you've turned into a sample because you're a subset. Variance. And once again, this is where it starts getting new for everybody. The variance is the average of the squares of the distance each value is from the mean. The average of the squares of the distance each value is from the mean. The average of the squares of the distance each value is from the mean. Average of the squares of the distance. Each value is from the mean. The symbol we use for this. Okay, we had big capital sigma. This is capital letter sigma. When we have a circle with a hat on it, we put a little bill of hat on top of it. Okay, that is a lowercase sigma. And it's squared. Okay? This is called the variance. How we calculate this? It's the sum of the values minus the mean divided by the sample size. So we have the sum of all the values minus the mean squared divided by our sample size. Or I'm sorry, population size. It's your population size. And why do we square it? To keep things positive. square these to keep things positive because we need to eventually take a square root, so we need to have positive numbers there. All right, to find our variance. Okay, we're going to find our variance for our values up above. So my values were 82, 94, 90, 88, and 86. Those are our values. Our next column, we want to take our value minus our mean. And then we're going to square that. So within your calculator, what you're able to do with your calculator is our first value is 82. So we have 82 minus 88. Hit enter. We get -6. Don't have to do anything but hit your square button right here. Hit your square button. Take your answer and square it. They give you 36. A lot of this you can do mentally. Don't need a calculator. So my first column, I have 82 minus 86, which is, or 88, which is -6. And then work yourself sideways. And then work down the column. So we have 94 minus 88, which is a value of 6. And then we square that. 36. 90 minus 88, which is 2. Squaring that, we get 4. 88 minus 88, we get 0. And then 86 minus 88, we get -2. And then we square that, we get 4. We add down our last column. So we have 36 plus 36 plus 4 plus 0 plus 4. We get a value of 80. Then our variance is the sum of x minus x bar, or mean, squared, divided by how many we have, which is 5. We have a total of 5 here. So we come down to a value of 16. Okay, what I want you to do the exact same thing with the second set of data. Take your x minus your mean, and then square it. Like I say, typically I suggest you work horizontally and then down the column. So you can just hold the value in your calculator and just hit the square button. Keynes, we add down this last column, what do we get? 1,000 what? So to find our variance, we take the 1088 divided by 5. Grace, what do you come down to? We had 217.6 as our variance. Once again, it's a relative concept. My variance is greater, so that means the spread of my data is going to be greater. My variance is smaller. That means we're going to be clumped together. Now, the more important part of variance is the standard deviation. This is one that's a lot more practical, a lot more used. The standard deviation is the square root of the variance. The square root of the variance. And how we signify the standard deviation is by just sigma. Just sigma. It says it's a 0 with the bill of the hat on it. So if we go back and find our standard deviation, our standard deviation here would be the square root of 16, which is a value of 4. Square root of 217.6. Oh, 14.75. Once again, relative concept. Okay, it's a relative concept. When working with a sample, when you work with a sample, the variance formula is altered to give a better estimate of the population. Once again, if we're working with a sample, we now use our Roman letters, an S, rather than sigma. Okay, Greek letters, we're in sigma. That's a population. Roman letters, we use our variable S, or letters S. What changes is we take sample size and we subtract 1. They say this gives a better estimate to a population standard deviation. Statistically, they say. But everything else on top is still the same. It's value minus the mean squared, but then we have n minus 1 on the bottom. Still the sum of your value, there should be a sigma in here. The sum of your values minus your mean divided by n minus 1. Sample standard deviation, just take the square root of it. Group data, we did this the other day. 2 days ago, group data. Look back in your notes. What did we calculate the mean to be in this group data? The 24.8, 23 point, 24.8. Is that what we came down to? 24.8 was our mean. We still have our midpoint. Okay, let's see, we had 9.5, 19.5, 29.5, and 39.5. Once again, you're going to want to work sideways with this. We have our midpoint minus our mean. Then we square it. And then we multiply by our frequency. So we have 9.5 divided by, or minus 24.8. We get negative 15.5. The next column, we're going to square that, so you can just hit your square button. 234.09. And then we're going to multiply by the frequency, which I think is 2. Yes, times 2. So we can multiply by 2. And that's going to give me my final column, 468.18. So you want to work sideways and then down. We took the 9.5 minus our mean. Then we square that. Then we multiply by the frequency. Okay, so take your 19.5 minus your mean. Square that. Then multiply by its frequency. And your calculator is a very nice tool to have. Does a lot of nice work for you. Okay, then we're going to add down the column. We're going to add down our last column over there. Hopefully I got my numbers right. And we have a total of 1015 here. So we're going to add down the last column and divide by 15 minus 1. Check your answer with somebody around you. And find the standard deviation, just take the square root, the else of the variance, and find the standard deviation. Yeah. Why didn't I?
I don't know.
I just don't like you.
Hey, maybe.
When we add down the column, what do we come down to when we add down the column, Mason?
I got 1,373.35.
1,373 point what? 35. And we divide that by 14. What do you come up with?
90.56.
90.56. And then to find the standard deviation, we take the square root of the 90.56. And what do you come up with? 9.51. Yes, no, maybe so. You good with the numbers? Close enough? My calculator, my brain stops there after a while. Empirical rule. Empirical rule. When a distribution is a normal distribution, which is a bell-shaped curve, it is symmetric. The symmetrical curve, it's a bell-shaped curve. What is important about the mean and standard deviation? We want to use the mean and standard deviation to be able to make predictions. If it is a normal bell-shaped curve, symmetrical distribution. 68% of the data will lie within one standard deviation of the mean. 68% of the data will lie within one standard deviation of the mean. Statistically, that's what they'll say. 95% of the data will lie within two standard deviations of the mean. And 99.7% of the data will lie within three standard deviations of the mean. If the mean is 71 and a standard deviation is 8, here's my mean of 71 right in the middle. My standard deviation is 8. So if I take our mean and add one standard deviation and subtract one standard deviation, we will go to 79 and 63. What the empirical rule states is that %68 of your data will lie between the values of 63 and 79. If we would take our X bar, add 2 standard deviations, which would be to 87. Just adding another standard deviation. And our X bar minus 2 standard deviations, which would give us 55. What the empirical rule states is that 95% of the data will lie between 55 and 87. Then if we go one more standard deviation, that would take us to 47 and 95. 99.7% of the data will lie between those 3 values. When you go to college, you have professors that they say will grade on the curve. We'll talk about that tomorrow, how they use standard deviations to determine your grade according to a curve. What I'd like you to do for homework is I would like you to find some standard variances and standard deviations of ranges. Now, in the bottom one, you have number 3, you have 2 rows of data. Make the first row males, the second row females. And find the standard deviation for both of those. So you'll be doing 2 different standard deviations. You'll want to set up a table. You want to be able to set up a table. Just do your data, just like I did here. Okay? You just have to set it up and work yourself through it. Eventually we'll work into your calculator as we go through the chapters, as we get into the second semester. We'll find easier ways to find the standard deviations, but for right now, I just need to learn how to calculate a standard deviation. All right, questions? QED, we is done.